LU factorization is splitting a matrix A into two parts, a lower triangle and an upper triangle. In a matrix like this would be the upper triangle and this would be the lower triangle. If we're given an example, A equals 2, 1, 0, 1, 2, 1, 0, 1, 2, to turn this into LU, we would use Gaussian elimination and row operations to turn this into REF form. Now normally REF form, row echelon form, would see this A matrix turned into a form where anything under the pivots would be 0. So these would be 0 in REF form, but LU factorization is a little different where we want to preserve the multipliers of the row operations. So how would we get A into REF form? Well, we want to get rid of these two values. We want to turn these into zeros, but we still want to preserve the multipliers. So we would subtract from from row 2 1/2 times row 1. So we would get A 2, 1, 0. This would be 0 normally, but since we're preserving the multiplier, and this is the multiplier right here, without the negative, without the subtraction, and we would save this here. Because later, we're splitting this matrix into two parts. Anything under the diagonal would be the L part of the split triangle. So we have 1/2 here, and then this is 3/2, and then this would stay the same, 1. Now we want to get rid of this one here. The row operation for that would be R3 minus 2/3 R2, and then we would get A equals 2, 1, 0, 1/2. I'm keeping it in blue to remind myself that this is a multiplier. And then this would be, we want to save this 2/3 right here, 2/3, and this would be 4/3. The 0 would just be 0. And now we can split this into L and U. So this is L and this is U. So what is L? Anything in the diagonal line. Let me actually do these in different colors. Let's do purple. L. Anything under the diagonal lines would be the lower triangle. Anything on the diagonal for L would just be 1s, and then above would be 0. So 1/2, 0, and 2/3. For U would be including the diagonal. So whatever was on the diagonal, we keep that for U. Anything under would just be 0s, and then we keep everything above as well. So normally, when you're told to split A into 2, you're also given a system of equations like AX equals B, and you're supposed to use this technique to solve for X, and you're also given B as well. So let's do an example. AX equals B, we're supposed to solve for X, and then B equals 1, 2, 3. We would use the equation LC equals B, then UX equals C. Because when we split this matrix, A matrix, into LU, it would look like this. This would be the new form. And then this part right here would be C. And we're using this equation with this newly created C to solve for X. So what was L? 1, 1, 1/2 and 2/3. 1/2 and 2/3. And this is L. LC, C1, C2, C3. This is equal to B, which is 1, 2, 3. Now C1 is given, since the other two values are 0. C1 is given as 1. C2, so we would subtract 2, we would subtract 1/2 from 2, so that would be 3/2. C3 would be, you plug in 3/2 into this equation. So 2/3 C2 plus C3 equals 3. This just becomes 1 plus C3 equals 3. C3 would be 2. So we solve for C, now we gotta solve for X. And we use the second equation right here. Ux equals C. Now what was U? 2 3/2, 4/3. 2 3/2, 4/3. What was above the pivot? 1 1. 1 1 and 0. Everything else is 0. This is the U that we figured out earlier. And then we have x1, x2, x3. And then we have C. 1 3/2 C. 1 3/2 2. X3 is easiest to figure out, so we'll go from bottom up. So 4/3 x3 equals 2. We multiply both sides by 3/4. That cancels out. 3/4. 1/2, 3/2. So x3, I'll put this here. X3 is 3/2. What is x2? 3/2 x2 plus 3/2 is equal to 3/2. Subtract both sides, that's 0. x2 is equal to 0. x2 is equal to 0. What is x1? 2 times x1 plus 0, because x2 was 0. 0 times 1 is 0. Equals 1. So x1 would be 1/2. x1 would be 1/2. And this is the solution that we got from using LU factorization to solve for x.